AMA. This week we have Shlomi presenting on Orchestrator. We're very excited to have him. So Shlomi, please take it away.
Hi, everyone. Thank you for being here or watching. So this session is about Orchestrator, and in the spirit of DBAMA, this is a no slides presentation. So what I thought about doing was to just run some stuff, just show off some of Orchestrator's functionality and slowly work this through to see how we can do like a little bit of scripting or how failovers work and some general tips. So before we begin, I'm going to just kick this Docker image, and while it loads, a few words about Orchestrator. So Orchestrator is an open source MySQL replication management, visualization, and high availability tool. I created it like 6 years ago while working at Outbrain at the time, and the company was happy to release it as open source. I later continued developing Orchestrator at Booking.com for the next year, and then for more years at GitHub, where Orchestrator was actually adopted by GitHub. So Orchestrator runs GitHub's and other well-known companies' failover and high availability. So a picture is better than 1,000 words, I guess. What I'm running now is a container that has like a full environment, a full demo or functional environment for Orchestrator to run. That includes, as you can see, a DB deployer sandbox of 4 servers. So we're going to run a replication cluster. And on top of that, we're going to run Orchestrator. And on top of that, we will also run a little bit of console and agent proxy to see a little bit about the high availability stuff. So Orchestrator works with a normal replication setup. I know Oracle is pushing hard towards the DB cluster and synchronous replication, but the asynchronous or semi-synchronous setup is, I guess, by far the most dominant setup out there. So this is the Orchestrator visualization. We're not going to spend a lot of time at all on this webpage. We're going to come back to command line and stay on the command line for the rest of this session. But I'm just pointing out that we've just ran a Docker image that runs Orchestrator, opens the ports towards my machine. So the browser we're in actually looks at the Docker image. You can all git clone Orchestrator and run that system on your machine. So it's a great playground for Orchestrator, and we're going to demonstrate quite a few things. So just like the one visualization that we're going to do is like this nice drag and drop for making a topology change. And for those who are not colorblind, you may notice that there's like different colors here. So Orchestrator identifies like the data center or the region where the servers are located, and helps us visualize that as well. So we're back at the command line where we're going to stay. We have this nice intro that illustrates how we should use Orchestrator. So we have this topology, and let's make it slightly more comfortable to read for the human eye. So we have this.
Shlomi, can you click on the hide button for that?
Sure. Oh, yes. I thought I was the only one who sees that.
No, we all see that.
Okay, good.
Thank you.
Thank you. All right, so we have this one master that's in 10111, and then these replicas. And you will notice that this server is the very one that I relocated over here. So these are basically the same. This is the same visualization on the web UI and on the command line interface. Both of them speak to the Orchestrator HTTP API, which we're going to utilize today. So I'm going to do like 4 stages. First stage is a little bit about topology refactoring, and then a little bit of scripting around that. The second stage is a little bit of demo around GDID, errand GDID, and a bit of the API. And then the third and fourth stages will be about graceful takeover and just failovers. So I'll take it off with some scripting. I'm going to relocate this server back into the original position behind the master. So that's a pretty straightforward operation. And now our topology is again flat. We have the master and 3 direct replicas. I could also relocate a bunch of replicas. So I could relocate all the replicas of the master to replicate from 10112. And the orchestrator command line outputs like a textual, well-parsable output. And later on, we'll see how it extracts that kind of output from the API. Okay, so far? Cool. So the next thing I want to show you is how you can investigate or interrogate the topology using Orchestrator. So which cluster instances? We have a cluster that's named CI. Which cluster instances, which are the instances in this cluster? Which are the replicas of 127? Did something change? Oh, yes. Okay, so we have one replica to 10111. We have 2 replicas for 10112. I could also ask which is the master for 10112, etc. So it's easy to investigate the topology. And this comes very handy with scripting. So for example, in this topology, we have a non-flat topology. Here's a nice script for you to flatten the topology, right? You want to put everything below the master. I don't know how the topology became to be as it is. So what we're going to do is look at all of the cluster's instances and one by one, relocate them underneath the master. And that will skip, the irrelevant servers like 10111 itself. So here's a nice script for you to flatten the topology. And there we have everything flattened. Likewise, things that we actually do with scripting. Let's set up semi-sync. Okay, let's enable semi-sync master on the master and semi-sync replica on all 3 replicas. So it goes enable semi-sync master on the master server. That'll do. It's basically the set global variables. And then let's enable on all the replicas. But wait, there's 3 of them. I'm not sure which they are. So to remember, we could ask, which are the replicas for 111? Oh, those are the ones. Great. And do the same trick from before. And enable semi-sync replica on all those replicas. Is that okay so far? Cool.
Looking good.
All right. So the topology output shows us actually that the master is indeed running with semi-sync and the replicas as well. I'm just pointing out that setting up like semi-sync on replica is not such a trivial operation. You need to both enable some variables, but then you need to also kick the IO thread. If you just set global semi-sync enable, that doesn't actually do anything. So Orchestrator is smart about those things. It really understands the rules for MySQL. If you want to enable semi-sync, it will do the restart of the IO thread for you. So that's like a first glimpse into the things Orchestrator is aware of and spares you from the need to know that. Cool. So let's just disable. I'm going to copy and paste a little bit. You'll indulge me as I don't type everything and just go ahead and copy paste stuff from my editor. Cool. So I'm going to just disable semi-sync because that's going to interfere with the rest of our operations. Nice. So we have this sandbox set up by DB deployer, and I'm going to run an operation. I'm going to do a flush slow logs on one of the replicas. Oops. Is that okay? Yes, no? Does anyone see a problem with what I just did? Anyone? Feel free. Well,
I'm
flush slow logs. Yeah, flush slow logs.
It will create an errand transaction.
Yes. Unfortunately and unjustifiably, flush slow logs will create a GDID entry, a GDID transaction on that replica. And now we have an errand transaction on that server. So that's pretty much inconvenient. And we want to fix it. But first we want to know that
sorry.
Yes.
Sorry, why do you only have an errand on 113 instead of on all of them?
I injected that query, I ran that query on S2, that's slave 2, which maps to this server.
Ah, I see.
Okay,
cool.
so I went directly to the replica and ran this command. And that's like a bad thing to do, but it happens. Yeah. And there's a set of various flush commands, which you don't expect them to create a GDID entry, because why would flush slow logs do that? But they do. So so that's an unfortunate situation.
Is that a statement that gets replicated from the master if I ran it on the master?
Can you say that again, please?
If I ran the statement on the master, would that get replicated to send to all replicas?
The flush slow logs. So the GDID transaction will replicate, but for this particular command, for flush commands, the replicas won't rerun it. They won't replay it.
Oh, okay.
Right. So there will be a GDID transaction on all the replicas. So with regard errand GDID, I want to introduce the replication analysis command. Usually we look at it for dead master situation, but Orchestrator also analyzes structural issues, such as, oh no, you have an errand GDID. You are going to run into trouble if that replica is to become a master, because, if that replica is to become a master and the binary logs for that transaction ID are purged. So that's like a risk. And we want to be able to fix that risk. So a few things about errand GDIDs. We can ask Orchestrator to fix it. And we can use this example now to look a little bit more into the Orchestrator API. How does Orchestrator see the GDID? What's the errand GDID? And how does the command line parse that data? So I want to jump in a little bit into the API before we actually resolve the errand GDID in different ways. The Orchestrator client script is just a shell script that runs an HTTP GET on Orchestrator's API. And basically it's a wrapper. It gets a JSON output and it parses that output using JQ and prints out a well-formed tabulated format. So what I'm going to do now, I'm going to ask Orchestrator client to actually run an API command for me. And let's begin with this command, show me all of the instances, and pipe into JQ. So this is what Orchestrator client really does behind the scenes. It runs HTTP commands, gets like full-blown JSONs, and from those it extracts the relevant information. So, for example, we can see the server with port 1033113. That's the server UUID. That's the master UUID for the topology. And here, that's the executed GDID set. All that is extracted like from MySQL, but Orchestrator is also able to identify the exact errant GDID. Let's print that out. Let's do a little bit of JQ magic to condense, to summarize the information. So I'm taking that same JSON and only extracting a few of the fields. So we have the master at 111, that's the server UUID. We have a replica, that looks good, that looks good. And here we can clearly see the errant GDID. We understand where that came from. No, it's not always so clear to see because sometimes we can see that it has this 3333 thing, which doesn't appear anywhere else. Sometimes these values can legitimately appear in other places, and it's more difficult for the human eye to catch. But we digress for now. We want to, what we're going to do now is, while we're looking at this API, let's look at a few interesting things I can do with the API. So, at my last job, we had to upgrade all our MySQL servers, and from time to time, we would want to check, how many of our servers are still running 5.7.23, right? That's actually an easy thing for Orchestrator to do. We're using Orchestrator as an inventory service. Now, Orchestrator only looks at production data, right? Possibly you will have some puppet set up that says otherwise, but Orchestrator sees what's in production right now. So it's easy to extract information from Orchestrator and say, right, let's strip this and say, and find out that we have 4 servers for 5.7.26. Or, again, I'm going to cut and paste. Orchestrator, can you please let me know which servers in the CI clusters have no replicas, which means they are leaf nodes, right? If we have time at the end of this presentation, I'm not sure we will have, but I'll want to show off like this extract from one of our more interesting scripts. You need to do those upgrades, right? I was telling you about upgrades before. How do you upgrade an entire cluster? You can't just go ahead and upgrade the master in place, right? You want to walk the tree. The first servers you'll be able to upgrade are the leaf nodes, those that have no subdependencies, right? Those are the servers you'll begin with. So that's relatively easy to pick. But you will then want to move on to intermediate masters if there are any such servers. And Orchestrator is the best tool to get that kind of information and to operate on that kind of information. So these API calls are just a glimpse into what we can do. Questions so far before we return to GDID? Right. There's 2 ways to fix errant GDID. I mean, there's 3 ways, and the third is to completely destroy the server and rebuild it from backup. That's also an option, but probably not what we're looking into. There's 2 interesting ways to do that. The one method is to apply an empty transaction with this GDID set onto the master. That empty transaction will go down, will drill down into all the replicas, and our 10113 replica, which already has this transaction, is going to ignore it, And so we're going to make everyone else make believe that this transaction exists. Does that make sense? That's just my skill stuff. So
it does. Just a semantic question. If it ignores it, does it binary log it if it has clients downstream? I guess if it has clients downstream, then they would have already processed it. If it wasn't a leaf node.
You're correct, Morgan. So it will ignore it. It will not push it down further downstream because it already has. And any new replica that never got the original transaction will get it again. So with GDID, the magic is that a replica knows what GDID entries it's missing and will request these from its master. Or rather, it kind of requests everything and then ignores what it already has. So the answer is that this just works as long as the binary logs haven't been purged yet.
That makes sense. Thank you.
Okay, so I'm going to inject an empty transaction based on the server, and what do we want to see? We want to run a topology again, and we see that there's no errant transaction. Let's run the JQ foo query, and we see that we've applied that same transaction onto all of the servers. So the next thing I'm going to do is I'm going to do that mistake again. Oh no, what have I done? Again, I have errant GDID, and this time, if I look carefully into the executed GDID set, it's much more difficult to understand why this server has an errant GDID, because all servers seem to have, like, give or take, the same 3333 stuff, right? But ours has an extra one, and that's really much more difficult for the human being to analyze and then to process correctly. So the other thing we can do to fix errant GDID on the server is to do a reset master on that server. And that's like a slightly more risky solution, because what we're going to do is completely purge the binary logs from these servers, from this server, and reset the GDID set. So that's another option. We just did that. There's no errant GDID, and that's it, I guess.
Shlomi, can you show us the internals of the first strategy where you inject an empty transaction?
Okay, so do you mean to show you in the code?
Yes.
Difficult questions. Sure. Let's drill down from the API. We don't want that. We want this one. Errant GDID inject empty. So what we want to do is this. We want to verify that the instance does indeed have GDID errant. If not, there's nothing to do. We want to find out who the master is. There could be two masters in case of a master-master replication. That also works. We need to actually run Oracle GDID. And then we're going to parse the set of GDIDs and explode it. So I only injected one transaction. What if we injected 100? What we would see here is not just, one, but like going up, where we had the errant transaction. We would see like 1-99 or something like that, right? And so we need to explode them because we need to inject them one by one, iterate on the exploded entries. Inject the 333 colon 1, 333 colon 2, 333 colon 99 until we've exhausted all of the errant GDID set. Does that make sense?
Yeah. Thank you.
Sure. I just wanted to point out that I could likewise run the, let's flush again, right? There's GDID again. I could likewise ask Orchestrator client to directly invoke the API to reset master. If I run most of these operations, I could also run from the web UI, click some buttons. That's what they will call. They will call the API to match this operation. So I'll get a JSON, a nice JSON code OK message. This is fine. And then the details would be like the updated status of the instance.
Okay, and
Shlomi, here's another question. If the master also had that RNGTID but was not at the correct position, let's say it was like 3 binlog files away, would a replica still fetch that transaction and apply it, or would that get ignored and remain errant?
Yes, they will, because they will notice that the master's executed GDID set contains this weird transaction they never heard of, and they will interrogate the master, give us that transaction. It will scan as much as it needs from the binary logs to give them that transaction.
So that means that if I decided to fail over to that replica, that will automatically fix all other replicas, right? Because it will request
yes.
If that replica still has those binary logs.
Exactly.
Yeah.
Because if some time has passed and those binary logs are purged, then the replica, you will run .slave, and the replica will say, I can't, because there's a missing entry and I don't know what to do with that, so I don't want to cooperate with you. That's why it's important to fix these things pretty quickly before binary logs are purged.
And do we have a way to see whether or not it will fail in that way? Like if we attempted to do such a failover, right?
Yes.
There are some queries around like determining what logs have and haven't been flushed, or what GTIDs you still have in whatever, like relay logs or something.
Yes. So a few things. I'll show you a few things. Let's flush logs again. We can. One of the things is that locate. One of the things that Orchestrator can help you with is to tell you in which binary log that specific the errand GIDs are located. There could be multiple binary logs, but in our case, that's the single binary log. So that's one thing. The other thing is that Orchestrator knows and prevents you from even attempting to relocate a replica below another server where replication will fail. It will prevent you from doing that in the first place. And that's pretty important. So again, if like server A or server 113, right, has lost the binary logs with this errand GID. I'm not going to simulate that right now because it's going to take a little bit of time, but if this server now purges the binary logs and that errand GID becomes lost forever, even though it's just a flush slow logs, it's meaningless, but MySQL doesn't know that. And at some time after that, you want to relocate 114 below 113. If you do that by hand, like stop slave, change master to start slave, it will fail. If you do that with Orchestrator, so if you ask Orchestrator to relocate 114 below 113, it will tell you up front, no, I'm not going to do that because I know this operation will fail because I've already done the math. It's important that Orchestrator tells you that because the change master to operation is destructive. It purges the relay logs from the server. And I've ran into situations in production where you say, okay, yeah, I want to put it below 113. Oh, no, it can't. No, I want to take it back. Oh, no, the relay logs are missing. And the master doesn't have the binary logs where, I got the relay logs and the master already lost that information. I was trusting these relay logs to exist. So Orchestrator prevents you from doing the mistake in the first place. Hope that answers the question.
Yes, it does. Thank you very much.
Cool.
Shlomi, you've been showing us this using the client. Can you run it? Can you run the server in a mode where it detects and reports errant transactions, errant GTIDs?
Yes, I mean, it does that all the time. If I
Okay.
show you the web interface right now, you'll see this warning, and that warning says there's an errant GTID structure. And you'll see this little red dot saying there's a GTID, there's an errant GTID, etc. So, but right now, Orchestrator doesn't make like a failover or fixes the GTID because it really doesn't understand what the change you did was. It doesn't look into the data. Maybe you did actually change some row, some data. It shouldn't have access to your data. So it cannot fix it. And you need to be observant enough to ask Orchestrator if everything is fine. And thankfully, the API allows that. So you can set up, at my previous job at GitHub, we would query the API for
So you set up
analysis.
So you set up monitoring around the API to detect these things.
Correct.
Okay.
So we did this, and you would get this. You would get maybe multiple structure errors or multiple replication errors or dead masters or lagging replicas, etc. And one of the things you would notice is I lost it. There it is. Errant GTID structure warning. There is an errant GTID on that cluster. From there, we would use Orchestrator to detect exactly on what server and in which binary log on that server. Usually with our automation, we shouldn't ever see GTID. So it would make sense for us, for a human being, to investigate why that GTID was there. So we would look into the binary log and run MySQL binlog and extract and look at the exact statement to validate that, oh yeah, it's a flush something, and not like an actual mistake that changes data. Is that okay?
And,
yes,
and one other question about the other strategy to fix a bin log, where you're resetting the master. This is essentially, I'm trying to remember these statements here, but stop slave, reset master, set global GTID purged equals like whatever it should be.
Yes.
Which is
set the executed,
should
set
be
the
being
purge.
the being what you get for your statement for your stop slave for your slave position after you stop slave, and then you are clearing out the errant things. Yeah, we usually do this by hand, so this is very handy for
cool
Orchestrator just to have something.
I have to confess, the GTID, the math really intimidated me for a long time, because the math is risky and it's complicated, and the master server is still running, still producing more GTIDs, and you need to make sure that am I missing something, because this just changed even while I was investigating. So thankfully I was able to code that into Orchestrator, and since then I'm a happier person. I really trust Orchestrator to do the right thing, and I prefer not to do that by hand. So
we're gonna change our docs to get people to use this instead. This will be better for us.
Shlomi, we have a question in the chat. The binary log detection to find out where the errant transaction is that cached, or is it basically interrogating the server live to find that?
It's interrogating the server live. You can run with MySQL show binlog events on a binary log. So show binlog events on MySQL-bin 0001. And the first few, there's like every binlog has a header. And the first headers say, what were the GTID events up to this binary log, right? Every binary log begins with declaring the executed GTID set at this time, before we begin writing to the binary log. And from walking the binary logs backwards in time, you can do the math of where your executed GTID set is. If the head of the binary logs indicates your errant GTID as part of the header, that means your binary log is in the future of the RNG-ready, right? It's already past the RNG-ready. So you need to walk backwards until you reach a server that doesn't know that RNG-ready. Hence, that's the binary log that contains it.
I also have a question, Shlomi. Do you have any, or do you force any order in which the servers are being processed for querying the executed GTIDs? Or can it happen that when you have a lot of servers, that your slave gets queried before your master, and Orchestrator doesn't know yet about the GTIDs on the master, but it knows it from the slave and it thinks it's errant?
Perfect question. Thank you, Matthias. And the answer is that this is taken care of. You are correct that, Orchestrator samples every server in its own good time, right? There's like you pull every server every 5 seconds, and you never know who gets there first. And it's possible that you will pull the replica and it will have it has applied transactions that were running on the master, but Orchestrator hasn't probed that master yet. And you would think that that server has an RNG-ID, but Orchestrator is a little bit smarter than that. And it identifies that these transactions can't possibly be errant because they're generated with the UUID, which is a parent of this server. Hence, it got them by virtue of replication. So it does the math for you. That's the short answer.
Thank you.
Okay, I want to move on from GTID because I don't want to spend too much time on explaining GTID itself, but more I want to move on to graceful master takeover. So a graceful master takeover auto, which is a new thing, is a way for us to do a planned failover. Maybe I want to take the master down for maintenance, I don't know, reboot, upgrade the Linux kernel, whatever, and I want to promote a different server because obviously I'm not going to take the master down while it's serving traffic. So I'm going to ask, hey, Orchestrator, can you please gracefully promote 10112? Sorry. What did I do wrong?
Dash I instead of dash D, no?
No. Oh, okay. Yeah, you're right. So I'll do it in a different way. So I'm going to say I want to. You're absolutely right. So I'm going to indicate either the master or the cluster which I want to fail over, and then promote another server. And what Orchestrator does for me is to promote the server I requested, right? It's going to, what it did was to set read-only on that server, set super read-only if applicable, make sure that 112 catches up with replication, relocate 3 and 4 under 2, promote 2, make 1 the replica of 2, and stop replication on 1. All right, so it's a long sequence of events, and Orchestrator automates that away from us. Now, something I haven't told you yet. Yes, please go ahead.
So in this case, replication is stopped on the old master after the takeover.
Right. On this command, or a graceful master takeover, which is what's in production right now, like in the latest Orchestrator release, Orchestrator will not kick replication on the demoted master. With this newly introduced command, not yet released, but it's in the master branch, it will restart replication. This is due to popular user demand. I didn't want to break the existing behavior in case someone depends on it. So sorry, new command to know about.
Cool.
So the next thing I didn't tell everyone is that there's HA proxy running on this server. It listens on port 13306, and console and console template route make the HA proxy configuration always route the queries onto the current master. So when we did this failover, Orchestrator updated console. So console and proxy are just one setup where you can do the master discovery with Orchestrator. That's just one setup that we worked with at GitHub. It was published on a GitHub engineering blog post called MySQL High Availability at GitHub. So I use the same over here. That's just to show that the orchestrator post failover hooks work. It talked to console. Something worked here, right? This actually made an impact. Let's do another failover, but before that, I'm going to do this operation. So I'm going to register 113 as a candidate. It's possible for me to prefer that some servers be promoted where possible over others. I could mark a server as a prefer, as neutral, as a prefer not, like maybe this is like a slow server, so preferably not, but worst case scenario, okay, or a must not, if that's like a dirty server or a developer's machine or something like that. So I just marked 113 as a prefer. And what I'm going to ask Orchestrator to do now is to just take over without letting it know where to. And I'm going to expect Orchestrator to figure out by itself what's the best server to promote. Hopefully, yes, thank you very much. It did promote 113. To validate that, we will run this query. Yes, like everything got promoted. The topology looks fine. Everything makes sense. Is that okay so far? Cool. Let's run another takeover. Just restore 111. I guess 111 is going to be promoted, and it did. And the next thing I want to do now is to try and promote a server which shouldn't be promoted. So before I run this, I will show you that the orchestrator config basically specifies prevent cross-region master failover. So with Orchestrator, I can tag servers with which data center they're on and which region they're on, right? Data center would be like USS 1, like whatever, USS 1A, USS 1B, etc. And the region would be like US East, US West, etc. So in this current setup, I allow Orchestrator to fail over onto servers in different DCs as long as they're in the same region. But wait, what are our regions? Let's see. So we're going to use the API again. Let's print the port and the region for all the servers. Cool. Oh, sorry, key port. So we have the master and the first two servers at region East and 114 at region West. At this time, I'm going to ask Orchestrator to do a graceful failover onto region West. And hopefully, right, recovery attempted, but no go. Orchestrator realized that this would break the rules. It did try, right? It did relocate those two servers below, but eventually didn't do the cutover, right? So we're still running without same old master, nothing changed. Does that make sense so far?
Shlomi, what does downtime mean in this output?
Right. So downtime is a feature for both Orchestrator and for us users to mark a server as, okay, so given a failover, let's say the master crashed. We will see that shortly. If a master crashed, Orchestrator is going to put it away and mark it as downtime. This means that Orchestrator will, from now on, pretty much ignore the server on things that relate to failover, right? It's like, it's an unknown situation. If we waited and we didn't, if we only waited for a couple, like 30 more seconds, Orchestrator would realize that this server is acting as an active master. It has the replicas. Everything looks healthy. The reason it was downtime was because Orchestrator was running like a forced failover. I told Orchestrator that I'm going to failover, and Orchestrator was preparing the server to be downtime so that it's being put aside. Maybe someone will want to take it out, etc. So a server which is marked as downtime will not be failover, and Orchestrator will ignore it when considering. There's a set of operations where a downtime server is okay to be ignored.
Right. But it seems like it comes back pretty quickly, which
correct.
is what I noticed in the previous examples.
Correct. So exactly. So if a downtime server is found to be part of a healthy replication stream, and actually it's a specific kind of downtime. It's called a lost in recovery downtime. But anyway, if that kind of server is found to be like healthy, replicating, and everything looks fine, that after a while Orchestrator removes that downtime. Same for an active master.
Okay. And one question on the cross-region failover. You had shown us that it doesn't work. So is there a way to check whether promoting to a particular replica would work before you attempt it?
I seem to think there is, but I can't. Let me get back to you on that.
Yes, that's fine.
I'm not sure. Yeah, it's like I feel like there is, and I'm not sure right now that you asked. So let me check that.
Shlomi, 9-minute warning or
yes.
8-minute warning.
Right. Sure. Okay. So I'll jump ahead just to the last demo. What I'm going to do now is completely crash a master unexpectedly to Orchestrator. And I'm going to create an interesting scenario. I'm going to mark 113 as the candidate server, right? That's the one I really want Orchestrator to promote, but I'm going to make things difficult for Orchestrator. What I'm going to do, where's that? Right. I'm going to stop replication on 113. So now it's the most lagging replica. I'm going to stop replication on 112. So if we are looking now at the topology, only 114 is in a good situation. And we know that 114 is not allowed to be promoted. The next best server in terms of replication is 112, but that's not a candidate server. The candidate server is in the worst status. It's the one where replication stopped ages ago. And we're going to now ask Orchestrator to fail over. So I'm going to, there's the server. Let's use the MyScale admin for shutdown. And then I'm going to run a tight loop of topology. So the 114 server still feels like the master is okay. There's no failover yet. But soon enough, there it is. 114 realizes the master is broken. 114 was half promoted. And take a look at that. Okay, we're done. That's the new topology. So let's step back and see what happened. We broke the master. Initially, it looked okay, but then it went shutdown. Orchestrator saw it was invalid. But that replica still thought the master was okay, so Orchestrator was not taking action. Until some point where everyone, all the replicas agreed that, yeah, there's no master. Like, we're not replicating. Orchestrator doesn't see the master. It kicks failover. It promotes 114 because it has the best binary logs, right? It's the most recent replica. But then it figures out, wait, I can't promote that. Let me see if I have a better alternative. I can't promote, I'm not allowed to promote because it's in a different region. So let's see if there's a better alternative. Well, let's gather 112 and 113 below 114. Let them catch up to 114. And then see which one of them is the better server. Oh, 113 was a candidate. That's the one we really want to promote. Let's make that a master. and then meanwhile move 112 below 113 until we reach that situation. So that's like a multi-step recovery, a more complex scenario where Orchestrator tries to get the best of the situation. And yeah, that's the final demo for today. That's the last thing I have time for today.
The seconds that are shown here, is that something that Orchestrator is computing from wall clock time, or is it computed some other way?
So this environment also runs the heartbeat process. And that heartbeat just goes into port 13306 through AJ proxy, and then, it's like PD heartbeat, right? But it goes through the AJ proxy, so it takes time until the proxy reroutes the traffic, and then Orchestrator uses that to compute. There it is. So Orchestrator is requested to use this query to timestamp diff, to use the heartbeat value injected by the heartbeat service. I always recommend using a heartbeat service. If not, like the seconds behind master value is not
reliable.
Right. With 8.0, this is supposed to be better. Orchestrator doesn't support it yet.
The other question I had was the replicas on which you had stopped replication, at some point replication started up on them as part of the failover process, right?
Yes, correct. Okay. That's because 114 took over. Go back. There it is. 114 took over and adopted those two servers from here to here. And because it adopted them, it asked them to pretty please catch up because I need to pass the mastership onto one of you.
Right.
More questions?
Did you have to set any configuration items for it to wait to catch up?
No.
Okay.
No. Yeah. No. Orchestrator will wait a finite amount of time for them to catch up. I think it's either hard-coded or configured to like 20 seconds. I forget right now if it's 10 or 20 seconds, but eventually it will time out. There are configuration variables for Orchestrator to what happens if all the replicas are terribly lagging. Should you wait until they have consumed the entire relay logs before you promote, or do you prefer to promote and lose data? Or do you prefer to maybe just abort the operation and let the user handle it manually? That's also an option.
Shlomi, one question. So if any replica having replication filters, should it be promoted as a master? So in that case is handled by Orchestrator?
Could you ask that again, please?
So let's say that I have 3 slaves and 2 of them are dead and one of the slave is active, but the slave having a replication filter, which means that I am replicating few databases on that particular slave. So how about this case?
Yeah, Orchestrator prefers to promote servers that don't have filters, but if that's like the only one, then that's the one it will promote. I would advise you to tag it with promotion rule, must not, or prefer not, etc. Maybe you never want to promote it, so tag it as must not. And so that Orchestrator will know not to promote that server. Replication filters are really a big pain. There's a set of operations which are, I think, practically unsolvable with replication filters. Like what happens if the intermediate master that's having that filter crashes? How to promote the next server? Usually, sometimes the replicas of the filtered intermediate master don't have the filter set up themselves, so that's like very risky to promote them. It's a difficult situation. So it's a little bit on you to help Orchestrator do the right thing.
Okay, we're at time, so I'm going to say thank you, Shlomi, and turn off the video. But Shlomi, if you have 5 or 10 minutes left over and people want to ask questions, are you available?
I am available, please.
Okay. Thank you very much. Stopping now.